So what we're talking about in this particular slide is Le Chatelier's principle. And that's simply a principle that states that a system in equilibrium can be subjected to a stress that causes an imbalance in that equilibrium. The system is going to naturally shift to counteract that stress. So what do we mean by a stress? There's a couple different things we can talk about. The addition or removal of a species that's involved in the equilibrium, changes in pressure for gaseous systems, and a heat gain or loss, which obviously is accomplished by changes in temperature. So let's take a look at this example right here. We have sulfur trioxide in equilibrium with sulfur dioxide and oxygen. So that would mean that all three species are present, and the rates at which they are reacting for the forward and reverse reaction is the same. So I could upset the equilibrium by simply adding a species. Imagine for a second that I were to increase the amount of sulfur trioxide. We know that equilibrium is based on reaction rates. If I increase the concentration of sulfur trioxide, that would mean that the reaction would have to proceed forward to get rid of the sulfur trioxide that I added, thus increasing the rate of sulfur dioxide and oxygen, while decreasing the rate of the sulfur trioxide until equilibrium is reestablished. If we were to remove a species, for example, removing the oxygen, if I were to take oxygen out of the system, it's going to no longer be in equilibrium. It will have to make up for the oxygen we removed by shifting towards that side. So in this particular case, adding more sulfur trioxide would shift the system towards the right to increase the amount of sulfur dioxide and oxygen present. If we were to remove oxygen, it would also shift to the right to make up for the oxygen we removed. So adding a species shifts away from the added species. Removing a species shifts towards that side. One of the other stresses we can put on the system in a gaseous equilibrium is a pressure change. We know that pressure for gases is similar to concentration for aqueous solutions. If I have a reaction that has different number of moles on both sides, pressure changes will affect the position of equilibrium. Our rule is if pressure increases, we're going to shift towards the side with fewer moles. If the pressure decreases, we're going to shift towards the side with more moles. That would make sense because we're trying to undo what we have done in terms of the stress. So if I increase the pressure, I shift to the side with fewer moles. By going to the side with fewer moles, it causes a decrease in pressure, thus reestablishing equilibrium. If pressure decreases, then it wants to increase the pressure by shifting to the side with more moles. For example, in this reaction, there are 2 moles of gas on the left and a total of 3 moles of gas on the right. So a shift towards the right would cause an increase in the number of moles, thus it would cause an increase in the pressure. Shifting to the left takes 3 moles and turns it into 2 moles, and that would cause the system to reduce in pressure. So again, Le Chatelier's principle is trying to undo what we did. In this example, if we increase the pressure, the system will shift towards the left because it has fewer moles. If we were to decrease the pressure, then it would have to shift towards the right, towards the products, to increase the number of moles. One of the other stresses we can introduce to a system is by adding or removing heat, by changing the temperature. We know that endothermic reactions are systems that absorb heat energy. Exothermic reactions are reactions that release heat energy. Now, how can we tell by looking at a reaction if it has an endothermic or exothermic reaction? We need to talk about something called enthalpy, which we abbreviate H. A change in enthalpy is talking really about the change in heat content. So we can think about this as the fact that each molecule has a certain amount of heat content built into its bonds. If a reaction loses that heat content, then clearly heat has to be released. Or a reaction can gain heat content by pulling heat in and using that energy within its bonds. So we can have positive increases in delta H gaining heat, and we call those endothermic processes. Or we can have a loss in the change of heat throughout the reaction, which is the exothermic process. So by simply looking at the sign of our delta H, we can determine whether or not the reaction is exothermic or endothermic. So exothermic reactions have the negative delta H, endothermic reactions have a positive delta H. So for this example right here, we're given a reaction, we're also given a delta H, a change in enthalpy. Again, enthalpy, think about heat content. There's a positive delta H here, which means that it's gaining heat, positive being gaining. We know that process is what? Endothermic. So for this particular reaction, what would happen if we were to lower the temperature of the system? Now, this is a little bit of common sense. This forward reaction, based on the sign of delta H, is positive, so we know the forward reaction is endothermic. So that must mean the reverse reaction is exothermic. Now, endothermic reactions are processes that want to gain heat. Is that easier to do in a warm environment or cool environment? If you need to gain heat, you obviously go into a place that's warm. Endothermic reactions prefer warmer temperatures. Now, the converse, reverse reaction in this case, exothermic reactions want to give off heat. So if you are out playing basketball on a hot day, you're very hot, where do you go to lose that heat? You obviously go into a cold environment. So, exothermic reactions are favored under cold conditions, whereas endothermic reactions would be favored under hot conditions. So in this particular reaction, the delta H is positive 62 kilojoules per mole. That's the amount of energy released per every mole. Gained per every mole. What would happen if I were to lower the temperature? Well, obviously lowering the temperature is going to favor the exothermic process. So what's going to happen in this case is it's actually going to shift towards the left, increasing the amount of HCl in that reaction. This one actually will change the K value at different temperatures. So changes in temperature will change the K value, which is why you see in most problems a K given at a given temperature. Shifting left would obviously cause the K value to decrease. Those are the three stresses we'll be considering when we're applying Le Chatelier's principle to reactions. Adding or removing species, changes in pressure, and changing the temperature of the system. I hope this helps. Thank you.